Good morning children. How are you all? Hope you all fine at home. Stay home, stay safe. Today's class we will discuss about chapter 14 in physics. Okay, what is the name of the chapter? It is electric current and its effect. Okay, in this chapter we are discussing about these concepts: electric components, heating effect of electric current, magnetic effect of electric current, electromagnet, electric belt. Okay, so these topics to be discussed now. Come children, let us see the chapter. See, what is this? This is an electrical circuit. See, electric circuit provides a closed path for the current to flow through it. Okay, see, this is the electric circuit. It always in a closed path. If it is in open, there is no flow of current. See, an electric circuit consists of a switch, battery, bulb and wire. It makes a closed path. So this closed path is known as electric circuit. See, the representation of electrical components by their conventional symbol. See, a switch, battery, wire and bulb are called electrical components. Okay, electric components. The symbols of a switch is this. The symbol of switch is this. Battery is this. This short line indicates negative terminal and the large line indicates positive terminal. Okay. And bulb. The symbol of bulb is this one. Okay. And it indicates the wire. So this is the electrical conventional symbol for electrical components. Okay. The next one. See, we know that a flow of charge through a circuit is known as electric current. Make a note. What is called electric current? A flow of charge in a circuit is called electric current. See, this current produces certain effects such as magnetic effect and heating effect. So in this chapter we are discussing about the effects of current. Okay, electrical current and magnetic effects. Okay, see, let us study about various electric components and the effects of current in this module. What is the name of the chapter? It is electric current and its effects. Okay, see, first we will discuss about electric components, which are called electric components. In general, the electric components consist of a switch, wire and a bulb and that battery cell. It consists of two terminals, one is positive and the other one is negative. So these are all the electric components. See, let us see one video about electric components. See the video children.
Let us study about some of the electrical components used in an electric circuit, such as an electric cell, a battery, an electric bulb, a switch, electric wire, electric cell. It is one of the sources of electrical energy. In an electric circuit, electric cell converts chemical energy into electrical energy. It pumps electrons through electric wires. You must have noticed that in an electric cell, there is a small metal cap on one of its side which indicates its positive terminal, whereas metal disc on the other side indicates its negative terminal. In the symbolic representation of an electric cell, the longer line represents its positive terminal, whereas thicker line, which is also shorter line, represents its negative terminal. Two or more cells, when joined properly, form a battery. this combination, the positive terminal of one cell is connected to the negative terminal of the other cell. The symbolic representation of a battery is shown. An electric bulb. It is a device which is designed to produce light and heat from electricity. Inside the glass chamber, there is a thin wire of tungsten called filament. The bulb is filled with argon gas. The symbolic representation of electric bulb is shown here. An electric switch. It is a device which is either used to complete or to break the electric circuit. If the switch is in on position, then the current flows through the circuit. Otherwise, in its off position, no current flows through the circuit. The symbolic representation of an electric switch in on and off positions is shown. Electric wire. It connects different electric components in an electric circuit and allows electric current to pass through them. The symbolic representation of electric wires is a single line. Besides these components, there are many other electrical components which we will study in higher classes.
What are the electrical components? Mainly it consists of switch, wire, bulb and the electric cell. The electric cell consists of two terminals. One is positive and the another one is negative. In an electrical circuit, the positive terminal is connected to negative terminal, and when the path is closed, the current will flow in the circuit. When we open the circuit, there is no flow of current. So this is about electric circuit and the electric components. Clear, children? The next one. See, this is a cell. We already know that a cell consists of how many terminals? Two terminals. One is positive and the another one is negative. See, connecting more than two cells which have positive and negative terminals on opposite sides. How we can connect these cells means, here the cells are placed one after the other such that the negative terminal of one cell is connected to the positive terminal of the adjacent cell. See, here there are three cells are there and two terminals. One is positive and the other one is negative. In this, a negative terminal is connected to positive terminal. Okay. The next one. See, these are also a cell. In this, connecting more than two cells which have positive and negative terminals on the same side. See, this is also a cell. Before we saw the cell consists of positive and negative terminal in the opposite side. But here in the same side they consist of both positive and negative terminal. How we can connect these cells means, here the cells are placed side by side such that a negative terminal of one cell is connected to the positive terminal of the adjacent cell. See, look at the image. Here this is positive, this is negative. Here the negative terminal is connected to the adjacent positive terminal. Again this negative is connected to positive like this. In this way we have to connect all the cells. Okay. The next one. See, a battery is represented by three continuous pairs of long and short lines in cascade. It means there and the larger one is positive terminal. Here what is the question? A battery is represented by three continuous pairs of long and short lines in cascade. It means what is the answer? The answer is the three cells in the battery. The correct option is three cells in the battery. How? See, in symbolic form, each cell is represented by a pair of longer line which represents the positive terminal. The longer line represents positive terminal, followed by a shorter and thicker line that is which represents the negative terminal of an electric cell. See, therefore three pairs represents three cells which combine together to form a battery. So what is the answer? It consists of three cells because three pairs represents three cells which combine together to form a battery. Okay. The next one. See, what is cell holder? Look at the image. It is called cell holder. This cell holder is connected in the circuit here. See, a cell holder has one or more compartments or chambers for holding cells. Look at the picture. How many chambers are there? There are three chambers. So we have to put three batteries here. So a cell holder has one or more compartments or chambers for holding cells. For dry cells, the holder makes electrical contact with the terminals of the battery. So it makes an electrical contact with this one and the electrical cell. So this is about cell holder. And the next one. What is called battery holder? See, holder for battery of 4 cells. This is 1, 2, 3, 4. So this is called battery holder. It has one or more compartments to hold the batteries. It makes electrical contact with the battery terminal. See, this one makes the electrical contact with the electrical cell. That is battery. And the next one. What is called a circuit diagram? See, a circuit diagram is a simplified conventional representation of an electrical circuit by using conventional symbol. We already know that an electrical circuit consists of it consists of switch, then electrical bulb, connecting wire and a battery. So, a circuit diagram is a simplified conventional representation of an electrical circuit by using conventional symbols of the electrical components used in the circuit. So this is called electrical circuit. That is called circuit diagram. See, this is closed circuit. In this, what are the electrical components included here? It consists of a closed key, battery, bulb and wire. So what is the symbolic representation of these electrical components? See, for key it is like this. This is the symbolic representation of key. For battery, we already know that it consists of two terminals. The shorter line indicates negative terminal and the longer one indicates positive terminal. So this is the symbolic representation of battery. And bulb. What is the symbolic representation of bulb? This shows the bulb. And this line indicates the connecting wire. See, when the key is closed, the circuit gets completed and the bulb closed. See, this is closed key. When the key closed, the electrical circuit, we already know that the closed path only make the current to pass through it. So, when the key is closed, the circuit gets completed and the bulb glows. Okay. The next one. See, in the open circuit, here the key is open. Open, key, battery, bulb and wire. The same symbolic representation. This is key, this represents battery, this represents bulb and this wire. See, when the key is open, the circuit remains incomplete and the bulb does not glow. Okay. Why? Because in the closed path only the electric current will pass through them. In the open path there is no flow of current. So the bulb does not glow. Okay. And the next one. Next we will discuss about heating of electric current? When a current is passed through a metallic conductor. What is called conductor? We already know that a conductor is nothing but it allows current to pass through them. If it does not allow the current to pass through them means then they are called insulators. Okay, don't confuse about conductors and insulators. Conductors allow the current to pass through them, but insulators does not allow the current to pass through them. The examples of conductors are copper and aluminium wire, but the examples of insulators are plastic. Okay, so here now we will discuss about the topic heating effect of electric current. It is nothing but if a current is passed through a metallic conductor, a heat will be produced. So that effect is called as heating effect of electric current. Okay. Let us see one video about this heating effect of electric current. See the video carefully, children.
We all see in our daily life the various applications of heating effects of electric current. Let us study about heating effect of electric current. Whenever a current is passed through a conductor, it becomes hot after some time. This shows that electrical energy is being converted into heat energy. We know that battery is one of the sources of electrical energy. The energy supplied by the battery can be used to run electric appliances such as to run the electric fan or to glow the electric bulb. The chemical reaction that goes within the battery generates the potential difference between its two terminals. This potential difference sets the electrons in motion, due to which current flows through the resistor connected to the battery. To maintain the flow of current in the circuit, the source has to keep supplying its energy. Can you think, where does this energy go? To maintain the value of flow of current in the circuit, the part of the electrical energy is consumed into some useful work, such as to glow the bulb, and the remaining energy may be utilized in generating heat in the gadget. This generation of heat is due to collision of electrons with the ions. The greater the number of electrons flowing per second, the greater will be the number of collisions. If the electric circuit is purely resistive, the energy continuously gets dissipated in the form of heat only. This is known as heating effect of electric current. The current through the resistor is actually the flow of negative charges, which are called electrons. Inside the battery, these electrons flow from positive terminal to negative terminal. The work done by the battery in moving the charge through a potential difference is VQ. Hence, the source must supply energy equal to VQ in time t. This increased energy gets converted to heat in the resistor. So the energy appearing as heat is given by H is equal to VQ. The charge that passes through the resistor in time t is Q is equal to square RT.
So, from this video it is clear about the heating effect of electric current. It is nothing but when a current is flows through a metallic conductor, the electrical energy gets converted into heat energy. So, this is known as a heating effect of electric current. Clear, children? The next one.
Heating
What are all the practical applications of heating effect of electric current? See, these are all the applications. Iron box and electric bulb. In this, which phenomenon we used means the heating effect of electric current. Here, when we this iron, for example, take an iron box. This consists of an wire node. When it is connected to a switch, the electrical energy gets converted into heat energy. Same like in electric bulb also. So these are all the practical applications of heating effect of electric current. Okay, and the next one. What is called miniature circuit breakers? We know about fuse. What is the use of fuse? In electrical circuit, we are using fuse, isn't it? What is the use of fuse? Actually, fuse is a safety device. When the current flows much or exceeds the limit, the fuse gets melting and it stops the flow of current. Okay, so in present days, we are using miniature circuit. See, this is called miniature circuit breakers. So, presently miniature circuit breakers are used in place of electric fuse. What it can do means, these circuit breakers automatically trips when the current in the electric circuit exceeds the safety limits. So, the miniature circuit and fuse do the same thing. What is the use of fuse or miniature circuit means? The fuse melts when the electric current flows or exceeds the limit. It can fuse and stop the flow of current. Miniature circuit also do the same thing. So these circuit breakers automatically trips means it can stop the flow of current. When current